risk for infection. And this risk for infection, ladies and gentlemen, is seen worldwide, particularly in the 15 developing nations that our team has traveled to in just the past couple of years. And in our search for leverage, we have found that there are indeed 200 million open wounds worldwide, 70 million of which are located in developing nations. And our expected cost for our device being $50, we expect that our total market potential at $3 billion.
So what is the need that is driving this market? People in developing nations need easier access to wound care technologies that are cost-effective due to the increased prevalence of deep tissue injuries. Now, imagine a farmer such as Marcelino gets into an accident which inflicts an open wound. If this wound becomes infected, there's a high chance for infection and amputation. His work life and ability to provide for his family are at stake. Pharmaceuticals that are currently on the market are effective at clearing the wound site, preventing infection, but the access to these pharmaceuticals is limited because of their high cost and lack of distribution to rural areas. We have developed a solution that cleanses wound fluid, which is known as exudate, a material that is detrimental to healthy skin production. We have found that a combination of salt, water, and growth factors can be extracted from this fluid, naturally producing a saline and growth factor product. This product can be then reapplied back to the wound site, cleansing the site, preventing infection from Marcelino, and furthermore amputation. This is a holistic approach to installation therapy, which is commonly used in the developed setting currently.
So our device has three basic components. The first component is the turtle vac. The turtle vac is a converted aquarium pump that's being produced in collaboration with Cone Health, a Raleigh-based nonprofit. It currently costs about $50 to manufacture. The second component of our design is the VacX exudate filtration system. This system is basically a syringe which is used to collect exudate, and then the syringe can be depressed in order to pass the exudate through a series of micro and ultra filters in order to produce an enriched saline. Lastly, we have the wound itself. When the turtle vac component of the system is being used, the wound is placed under 125 millimeters of mercury suction. However, when the VacX system is being used, the wound is at atmospheric pressure and being irrigated with the newly produced saline. Speaking of the VacX system, it's basically an array of micro and ultra filters that filter exudate into a saline solution that's also enriched with growth factors. We have microfilters that are used to remove debris and bacteria, as well as the ultrafilters, which can remove proteins and proteinases, which can lead to the development of chronic wounds.
So now that we've introduced our overall design concepts, which can be found outside in the lobby at the poster session, we must admit that we as a team have a grander vision for our device. This vision, which we call EcoVax, is expected to have a Class 2 510K regulatory pathway, but even more so is expected to meet our user needs even more in developing nations, as well as meet our product requirements of maintaining durability, being completely portable, and not relying on external energy sources. So you ask, how are we going to do this? We are going to create a modified turtle vac system that is completely portable as well as solar powered, combine it with our very holistic and sustainable approach of our VacX system into a backpack to create the EcoVac system. We care about the future of wound care, and we believe that the EcoVac system is the future. We would be remiss if we didn't acknowledge some of our lead collaborators on this initiative, as well as those that we'll depend on in the future. We have special thanks to Rex Wound Care, Nash Wound Care, and Cone Health, with a special recognition to Jeff Coves. Even more so, we are very grateful for the opportunity that we had to represent NC State at a national design competition at Rice, where we learned a lot of insights to simplify our device. In addition, we are also grateful for the local opportunities at the PDMA and E-Games competitions. We care about the future of wound care, but even more so about the livelihood of those affected by its shortcomings. With that, I'm Wade Colburn.
I'm Michael Peter.
Happy Zafar.
And we are Physique Medical.